Vivekananda Vidyalaya Metric Higher Secondary School, Rameshwaram. Date 11 November 2021. Today's thought: anything that makes you weak physically, intellectually, and spiritually, reject as poison. Class 11th. Topic: Kinematics. Subject: Physics. Introduction. Physics is basically an experimental science and rests on two pillars: experiment and mathematics. 2000-3000 years ago, the Greek librarian Eratosthenes measured the radius of the earth. The size of the atom was measured much later, only in the beginning of the 20th century. The central aspect in physics is motion. Motion is found at all levels, from microscopic level to macroscopic and galactic level. In short, the entire universe is governed by various types of motion. The study of various types of motion is expressed using the language of mathematics. How do objects move? How fast or slow do the objects move? For example, when 10 athletes run in a race, all of them do not run in the same manner. Their performance cannot qualitatively record by the usage of words like fastest, faster, average, slower, or slowest. It has to be quantified. Quantifying means assigning numbers to each athlete's motion. Comparing these numbers, one can analyze how fast or slow each athlete runs when compared to others. In this unit, the basic mathematics needed for analyzing motion in terms of its direction and magnitude is covered. Kinematics is a branch of mechanics which deals with the motion of object without taking force into account. In Greek word, kinema means motion. Concept of rest and motion. The concept of rest and motion can be well understood by the following equation. Figure 2.1. A person sitting in a moving bus, is at rest with respect to the fellow passenger, but in motion with respect to a person outside the bus. The concept of rest and motion have meaning only with the respect to some reference frame. To understand the rest or motion, we need a convenient fixed frame of reference. Frame of reference. If we imagine a coordinate system and the position of an object is described relative to it, then such a coordinate system is called a frame of reference. At any instant of time, the frame of reference with respect to which the position of object is described in terms of position coordinates x, y, z. That is, the distance of the given position of an object along x, y, and z axis is called Cartesian coordinate system, as shown in figure 2.2. It is noted that if the x and y and z axis are drawn in anti-clockwise direction, then the coordinate system is called as right-handed coordinated system. Though the coordinate system do exist in physics, we conveniently follow the right-handed coordinated system as shown in figure 2.3. The following figure 2.4 illustrates the difference between the left and the right-hand coordinated systems. Point mass. To explain the motion of the object which has a finite mass, the concept of point mass is required, and it is very useful. Let the mass of any object to be assumed to be concentrated at a point, then this idealized mass is called point mass. It has no internal structure like shape or size. Mathematically, a point mass has finite mass with zero dimension. Even though in reality, a point mass does not exist, it often simplifies our calculation. It is to be noted that the term point mass is a relative term. It has meaning only with respect to frame of reference and with respect to the kind of motion that we analyze. Examples. To analyze the motion of the earth with respect to sun, the earth can be treated as a point mass. This is because the distance between the sun and the earth is very large compared to the size of the earth. If you throw an irregular object like small stone in the air to analyze its motion, it is simpler to consider the stone as a point mass as it moves in a space. The size of the stone is very much smaller than the distance through which it travels. Types of motion. In our day to day life, the following kind of motion are observed. Linear motion. An object is said to be linear motion if it is moves in a straight line. Example, an athlete running in a single track, a particle falling vertically downwards to the earth. B. The circular motion. Circular motion is described as the motion described by an object traversing a circular path. Example, the Browning motion of the stone attached to the string. Rotational motion. If any object moves in a rotational motion about an axis, the motion is called rotation. During rotation, every point in the object turns with a circular path about an axis, except the point located on the axis. Examples, rotation of the disk about an axis through its center, spinning of the earth about its own axis. These two rotational motions are shown in figure 2.6. Vibratory motion, if an object or particle executes as to and fro in the vibratory motion. This is sometimes also called oscillatory motion. Example, vibrating of the string in a guitar. Movement of a swing. This motion are shown in figure 2.7. Other type of motion like elliptical motion, helical motion are also possible. Motion is 1, 2 and 3 dimensional. Let the position of the particle in space be expressed in terms of rectangular coordinates x, y and z. When the coordinates change with the time, then the particle is said to be in a motion. However, it is not necessary that all the 3 coordinates should together change with time. Even if 1 or 2 coordinates change with time, then the particle is said to be in a motion. Then we have following classification. Motion in one dimension, motion in dimensional motion is the motion of the particle along the straight line. This motion is sometimes known as rectilinear motion or linear motion. In the motion, only one of the 3 rectangle coordinates specifying the position for an object with time. For example, if a car moves from a position A to position B along the x direction, as shown in figure, then a variation in the x coordinate is noted. Thank you.